Here's integrated 3. It's problem 2-137. Here's letter A. It says, use the correct method from problem 2-136 to change each of the following equations to graphing form. Then without graphing, state the vertex and the equation of the line of symmetry for each parabola. So this first parabola, we're going to use the correct way. We already talked about the correct method from problem 2-136 is this way over here. The difference between these two ways is that when they added the number of tiles that it would take to complete the square, over here, they added 9 inside, and so they have to add 4 times 9 to the left-hand side because there's 4 here. This one, they added 9 in here, but then they didn't add 4 times 9 over here. So I'll show you what I mean. So we're going to go ahead and just go through the steps. So the first thing is these are like those tiles, like those constant tiles, the little square tiles. We're going to get rid of those on both sides. So we're going to say y minus 7, like this. And I'm making room right here for the special number that completes the square. But first, I see that this is not just an x squared, it's 2x squared. It's going to be hard for me to make, like with my tiles, it's going to be hard for me to make a square out of that. So I'm going to factor out the 2. And that'll give me x squared minus 4x. And I'm leaving a great big gap right here because I want to put the number that's going to make this make a perfect square. So that's what I'm going to put over there. And then I've got my y minus 7 over here. So what is the number that makes a perfect square? Well, this is x squared now. And then I've got negative 4x. So if this is like a little picture of those tiles that we were working with today, you might know that number right there, that's how many tiles I need to complete the square, and that's going to be 4. If I add 4 to the right-hand side, if I just willy-nilly put a 4 here, I'm really adding 8 because it's 2 times 4. So I have to add 8 over here. Okay, this thing right here can be rewritten as x minus 2 squared. And if that doesn't make sense to you, look at your model that you just made. This little trinomial right here, there's my x squared, there's my negative 4x's, and there's my 4. That gives me x plus 2 times x plus 2. X minus 2. These are negative x's. X minus 2 times x minus 2. So that's why this is x minus 2 squared. Okay, and then negative 7 plus 8, that gives me 1. So then I get y equals 2 times x minus 2 squared minus 1. Okay, so this is my equation. And it says without graphing it, I'm supposed to give the vertex. Well, the vertex is very easy because I know that h and k is my vertex. So this is x minus h, so h must be 2. And then k is always on the end, so it's going to be 2 and negative 1. And then the line of symmetry, if I did have a parabola with that vertex, the line of symmetry is just going to be the x number that the line is, that I can draw a vertical line through that would, be a line of, like a reflection line, a line of symmetry. So it's going to be x equals 2. Okay, let's do another one. So the next one is, I'll write it down over here, letter B. It says y equals 5x squared minus 10x minus 7. Okay, so the first thing we want to do is just think about your algebra tiles. Even though we might use some of these tiles, these are like these little guys. Let's just, to be neat and tidy, let's just get them on the other side for now. Just make them all go over there. So I'm adding 7 to both sides. Okay, then that gives me 5x squared minus 10x. Okay, I'm just getting rid of these, putting them over there, getting them out of the way. Now, I want to complete the square, like, use my tiles or whatever, but I can't because I've got 5x squared tiles. That's not going to make a square. So I'm going to factor out. I see that I can easily factor out a 5. Leave room inside the parentheses because there's some number that's going to make this be a perfect complete square. And we're going to figure out what that number is. Now I know I don't really have to draw this every single time. I know that I can just, oh, actually that's not even the right drawing. There's only negative 2x, so it would be, there'd be 1 here and 1 here. Right, this is x squared, this is negative x and negative x. So this right here is just 1. So it really only takes 1 tile to complete the square. If you don't want to draw the picture, you just take half of the x's, like half of negative 2 is negative 1, and then square it. So negative 1 squared, well, that is 1. So I added a 1 inside the parentheses, but if I pay attention to my 5 out here, what I really added to the right-hand side of the equal sign is a 5. So I'm going to add also a 5 to this side. So that'll give me y plus 12 equals 5. Now this thing I could write it as x plus, no, not plus, x minus 1 times x minus 1. That's what this area model is. It's x minus 1 squared. Oh, and then I can subtract 12. So y is equal to 5 times x minus 1 squared minus 12. This is the equation, and then I need a vertex. I can just get that from h and k, x minus h, so h must be 1, k must be negative 12. That's my vertex, and my line of symmetry would be just my x value, which is 1. So let me check that and make sure that's right. Yep, and that's how you do them.